In this video, I'm going to cover some examples relating to complex fractions. Recall that a complex fraction is a quotient of one or more fractions in the numerator, denominator, or both. So something of this form, 3 plus 1/2 over 5 over 6 minus 2/7 is an example of a complex fraction. I'm going to use two methods to simplify complex fractions. The first method, which I'll refer to as method number 1, is as follows. First, we are going to write the numerator and denominator as single fractions. Next, we're going to change the complex fraction to a division problem, which, remember, division is the same as multiplying by the reciprocal. And once we do that, we'll finally write our answer in lowest terms. The next method, which I'll refer to as method number 2, goes as follows. First, we're going to find the least common denominator, or the LCD, of all of the fractions within the complex fraction. This is equivalent to finding the least common multiple of all of the denominators we see in our expression. Second, we're going to multiply both the numerator and denominator of the complex fraction by this LCD. And finally, we're going to write our answer in lowest terms. I'm going to go over these three examples, and to do that, I'm going to use both methods, method number 1 and method number 2. Let's look at the first example, which is simplifying the complex fraction 2 over 3 plus 5 over 9, all divided by 1 over 4 plus 1 over 12. For that, I'm going to use the first method. To do that, I'm going to start by writing the numerator and denominator of my complex fraction as single fractions. We have 2 over 3 times 3 over 3, so I'm taking a common denominator. The least common denominator of 3 and 9 is 9. So how do I write 2 over 3 as a fraction over 9? I have to multiply it by 3 over 3. Plus 5 over 9 times 1 over 1. Divided by the least common denominator of 4 and 12 is 12. So how do I write 1 over 4 as a fraction over 12? I have to multiply it by 3 over 3 plus 1 over 12 times 1 over 1. That's equal to 6 over 9 plus 5 over 9 over 3 over 12 plus 1 over 12. That's equal to 11 over 9 over 4 over 12. And this concludes the first step of method 1, namely writing the numerator and denominator of our complex fraction as single fractions. Now I'm going to turn the problem into a division problem as follows. That's equal to 11 over 9 divided by 4 over 12, which in turn equals 11 over 9 times the reciprocal of 4 over 12, which is 12 over 4. That's equal to 11 over 9 times 3. 12 over 4 is 3. Now 3 over 9 simplifies as 1/3. We get 11 over 3, which is our final answer in lowest terms. So simplifying our complex fraction gives us the final answer of 11 over 3. Now I'm going to solve the same problem using method number 2. To do that, I'm going to find the least common denominator of the fractions 2 over 3, 5 over 9, 1 over 4, and 1 over 12. But that's equivalent to finding the LCM of 3, 9, 4, and 12. So LCM of 3, 9, 4, and 12 is equal to the LCM of 3 squared, 2 squared, and 2 squared times 3. What I did here is I wrote each of those numbers as the product of its prime factors. To find the LCM, I'm going to look at the highest power of each prime and multiply them together. So that's 2 squared times 3 squared. And that's equal to 36. Now I'm going to multiply the numerator and denominator of my complex fraction by 36. This gives 36 times 2 over 3 plus 5 over 9 over 36 times 1 over 4 plus 1 over 12. 36 times 2/3 is the same as 36 over 3 times 2, which is the same as 12 times 2, that's 24. Plus 36 times 5 over 9 is equivalent to 36 over 9 times 5, which is equivalent to 4 times 5, and that's 20. In the denominator, 36 times 1/4 is 9, and 36 times 1 over 12 is 3. That's equal to 44 over 12. Now 44 is 4 times 11, and 12 is 4 times 3. After canceling the 4's, we are left with 11 over 3, which is our answer in lowest terms. Notice how it is the same exact answer we got from method number 1. Next, let's simplify the complex fraction 6 plus 3 over x, all divided by x over 4 plus 1 over 8. First, I'm going to use method 1 to simplify. So we'll write the numerator and denominator as single fractions. We have 6 times x over x plus 3 over x, all divided by x over 4 times 2 over 2 plus 1 over 8. That's equal to 6x plus 3 divided by x, all divided by 2x plus 1 divided by 8. And this concludes step 1 of our first method, namely to write the numerator and denominator of our complex fraction as single fractions. I'm going to move on to step number 2, which is converting this problem into a division problem. So we have 6x plus 3 over x divided by 2x plus 1 over 8. That's equivalent to 6x plus 3 over x times the reciprocal of 2x plus 1 over 8, which is 8 over 2x plus 1. That's equal to 6x plus 3. We can factor out a 3 from that. We have 3 times 2x plus 1 over x times 8 over 2x plus 1. We can simplify 2x plus 1, and that leaves us with 3 times 8 on top. That's 24 divided by x. That's a fraction in lowest terms, and that's the simplification of our complex fraction. Now I'm going to use method number 2 to simplify. So I need the LCM of all of the denominators within my complex fraction. These are x, 4, and 8. It's easy to see that the least common multiple of x, 4, and 8 is 8x. This is the simplest expression that is divisible by x, by 4, and by 8. Now I'm going to multiply the numerator and denominator of my complex fraction by 8x. We get 8x times 6 plus 3 over x divided by 8x times x over 4 plus 1 over 8. 8x times 6, that's 48x. 8x times 3 over x, that's 24. 8x times x over 4, that's 2x squared. And 8x times 1 over 8, that's simply x. In the numerator, I can factor out a 24. That leaves me with 2x plus 1. In the denominator, I can factor out an x, which leaves me with 2x plus 1. Canceling out 2x plus 1 leaves us with 24 over x, which is the simplified form of our complex fraction. Again, note that it gives us the same answer as method number 1. Finally, let's look at example 3. Let's simplify the complex fraction 3 over x plus 2 minus 4, all divided by 2 over x plus 2 plus 1. Let's see that using method 1 first. I'm going to write the numerator and denominator of my complex fraction as single fractions. We write 3 over x plus 2 minus 4 times x plus 2 over x plus 2. All divided by 2 over x plus 2 plus 1 times x plus 2 over x plus 2. That's equal to 3 minus 4 times x plus 2 over x plus 2, all divided by 2 plus x plus 2 divided by x plus 2. That's equal to, let's simplify, 3 minus 4x minus 8 over x plus 2 divided by x plus 4 over x plus 2. One more step before we turn the problem into a division problem. That is minus 4x minus 5. This is 3 minus 4x minus 8 divided by x plus 2 divided by x plus 4 over x plus 2. Now we have written the complex fraction. We have written the numerator and denominator of our complex fraction as single fraction. Now let's convert the problem into a division problem. That's equal to minus 4x minus 5 divided by x plus 2 divided by x plus 4 over x plus 2. That's equivalent to minus 4x minus 5 over x plus 2 times the reciprocal of x plus 4 over x plus 2, which is x plus 2 over x plus 4. We simplify x plus 2 to get minus 4x minus 5 divided by x plus 4. Using method 2, we need the LCM of all of the denominators, namely x plus 2, x plus 2. Well, that's x plus 2. So we multiply the numerator and denominator of our complex fraction by x plus 2. X plus 2 times 3 over x plus 2 minus 4 divided by x plus 2 times 2 over x plus 2 plus 1. That's equal to x plus 2 times 3 over x plus 2, that's 3, minus 4 times x plus 2. In the denominator, x plus 2 times 2 over x plus 2, that's 2, plus x plus 2 times 1 is x plus 2. That's equal to 3 minus 4x minus 8 divided by x plus 4, which is equal to minus 4x minus 5 divided by x plus 4, and that's our final answer. Again, notice it gives the same answer as using method 1.